Hi, welcome back. This is Miss McClellan here to go over IM2 5.1.4 with you. And today we will be writing equations for quadratic functions. Okay, first learning goal, number 1. I will be able to write a quadratic function from a table or graph using the zero product property in reverse and any third point. And number 2, I will be able to convert from factored form to standard form. Time to start. Okay, 5-39, table 2 equation. You know how to make a table for a quadratic function, but how can you write an equation when given the table? Write an equation for each table below. What clues in the tables help you determine the equations? Verify that your equations are correct. Well, however, could I start? Let's see. I'm going to start with my x-intercepts. I have x-intercept. Whenever y is 0, I have an x-intercept at -3, 0, and 2, 0. I'm going to start out writing my equation right now. I think it's going to look something like this. Y equals x plus 3 times x minus 2. Because if I were to plug 0 in for y and solve for x, this would get me -3 here and +2 here. That might be right. Let's see if it works for another point. I'm going to test this by plugging in another point. Any point at all. I like this one because the numbers are small and positive. Okay. So I'm plugging in 6 for y and 3 for x, and I'm going to see if I get a true statement back. Plugging in 3 for x. Okay, this claims that 6 equals 3 plus 3, which is 6 times 1, and that's true. So this equation is correct. Heyo. The only thing is, we don't usually see equations written like this. I want to write it in standard form. Okay, let's see about that. I'm going to multiply out my factors. I have x squared, 3x, -2x, and -6. Add my like terms, which gets me y equals x squared, 3x plus -2x is positive x, plus x minus 6. Done. Okay, part B. Same method. X-intercept. That's whenever y is 0. So I have x-intercepts at -5, 0, and 1, 0. So I think my equation is going to look something like this. Y equals x plus 5 times x minus 1. And I'm going to test it with a third point. I like this point because the numbers are positive and small. And to me, I like positive small numbers. So I'm going to plug in 7 for y and 2 for x. 2 plus 5 times 2 minus 1. That 7 equals 7 times 1, which is a true statement. meaning my equation is correct. Now I'm going to convert it to standard form. X squared, 5x, negative x, and negative 5. I combine my terms, and I have y equals x squared plus 4x minus 5. There we go. Okay. Next problem. Gwen is stuck while trying to write the equation for the quadratic function in the following table. Our teammate says, this looks like part A of the problem we just did, except the y values are doubled. Let's see what her teammate's talking about. When x is negative 4, y goes from 6 to 12. When x is negative 3, y is 0. When x is negative 2, y goes from negative 4 to negative 8. When x is negative 1, y goes from negative 6 to... Okay, yeah, I see it. All these y values are the same as those except times 2, and the x's are all the same. All right. Well, how can that help us? Use Sadie's observation to write the equation of the quadratic function given in the table below. Well, I'm going to start as always. I think that it's going to look something like this. Based on my x-intercepts, they're the same as they were in the first problem. All right, I'm going to plug in a third point and see if it works out. I think I'll do 3 and 12 because, I mean, 3 and 12 they're my smallest positive numbers, and I like those. Okay, I'm putting in 12 for y, and I'm going to put in 3 for x. 3 plus 3 times 3 minus 2. This is 12 equals 6. False. The question becomes, how do we do this? But what I want you to notice is that all of the y values in this table are doubled, meaning this y should be half of this y. What happens if I just put a 2 in front of my equation? Then this becomes true. Look, everybody, it turns out you kind of always have to check if there's a number right there. We've been setting things up as y equals, for example, up here, x plus 5 times x minus 1, y equals x plus 3 times x minus 2. These are special, easy cases, but there's something we have to do. Normally, I would set this up as y equals a, x plus 3 times x minus 2. Then I would take any third point here, 3 and 12, and I'd plug that in. So I get 12 equals a, 3 plus 3 times 3 minus 2, which gets me 12 equals a times 6. And then I solve for a. And this number a is the value that corrects for how narrow or tall my parabola should be. So divide both sides by 6, and I get a equals 2, which means that the real equation for my parabola is y equals 2 x plus 3 times x minus 2. So basically, we need to introduce this extra step. But other than that, everything should be the same. So this is going to be y equals 2 times x squared plus x minus 6. I don't want to multiply this out again. I've already done that work up here, which becomes y equals 2x squared plus 2x minus 12. If I multiply the 2 into each term, and that's my final answer. Okay, deep breath, we're going again. Again, here we see another problem. We're back to the water balloon contest from 5.1.2. Remember IM's water balloon launch? Since the water balloon landed on the computer, you were given only a table of data, shown below. Write an equation that represents the height of IM's balloon as it traveled through the air. Okay. So I'm starting with my intercepts. 2, 0. But look, I only have one x-intercept. I have to use my reasoning skills here. I know that parabolas are symmetric. I notice that my parabola has values that go up to 25 and then down again, symmetrically. On either side of 25, we've got 24. On either side of that, we've got 21. Using that symmetry, I can continue this pattern. On either side of 21, I've got 16. On either side of 16, I've got 9. On either side of 9, I've got 0. And then I just continue to count upwards for my x's. So 9, 10, 11, 12. Okay. Now I see that I have x-intercepts at 2, 0, and 12, 0. And I set up my equation. I'm going to put an a in this time. Y equals a x minus 2 times x minus 12. Now I'm going to take any third point and solve for a. I like this point because the numbers are small and positive. I'm going to use 3 and 9. 9 equals a times 3 minus 2 and 3 minus 12. 9 equals a times 1 times negative 9. 9 equals a times negative 9. And in order to make that true, a must be negative 1. So my equation looks like this. Y equals negative x minus 2 times x minus 12. Now I want this in standard form, so I'll multiply it out. X squared here, x times negative 2 is negative 2x. X times negative 12 is negative 12x. Negative 12 times negative 2 is positive 24. Okay, almost done. I have y equals negative, don't forget that negative, x squared, combine like terms, this becomes negative 14x plus 24. And I factor my negative sign in. And I get y equals negative x squared plus 14x minus 24. And that's the final answer for that one. Next page when you're ready. Do, 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 do. Okie dokie. Here we write out step by step how to do this. So given this table, we're going to find the equation. Here, P and Q are the x coordinates of the x-intercepts. I don't know if that part's useful. I don't think it is. Let's cross it out. It's true, but it's just one too many things. And A is a factor that can be determined by any third point of the parabola. Keep it if it's good for you, but for me, it's one too many thing to look at. So I'm crossing it out. Kind of a personal preference. Okay, first step. First step is to identify the x-intercepts from my table. That's wherever the y coordinate is equal to 0. Right? Because when I'm graphing, y is 0 for every point on the x-axis, and I'm talking about x-intercepts. Okay, so Here's one of those, and here's another. My x-intercepts are -3, 0, and 2, 0. Now I write the equation in factored form. Keep in mind, you need your a there. You don't know whether or not a is going to have a value other than 1. So this becomes x plus 3 and x minus 2. Careful that you remember to switch the signs. This happens because we're doing the zero product property in reverse. So if this had been equal to 0, I would have solved x plus 3 equals 0 to get -3. If this were equal to 0, I would have solved x minus 2 equals 0 to get +2. To account for that change in sign that happens when we're solving for x-intercepts, we also need to change the sign when we're going backwards from x-intercepts into the equation. This is our use of the zero product property in reverse. X is -3. I add 3 to both sides, and I get x plus 3 equals 0. That's why one of my factors is x plus 3. X is equal to 2. I subtract 2 from both sides. I get x minus 2 equals 0, and that's why my other factor is x minus 2. So we write our equation in the form y equals a x plus 3 times x minus 2. Okay, next, we need to use any third point except the x-intercept to solve for a by substituting x and y into the equation. All right, the reason you can't use one of the x-intercepts, by the way, everybody, is because that would just send everything to 0 and it wouldn't get us what a equals. All right, I'm going to choose a third point from my table. I like 312 because I like my points to be easy. And I like these, they're both positive and kind of small. So I'll use 3, 12. You don't have to use this point. A lot of the time people like to use the y-intercept. This is the one I'd like to do. Okay, so my point will be 3, 12, and I'm going to plug it into my equation. Y equals, oops, sorry, got to plug 12 in. 12 equals a times 3 plus 3 times 3 minus 2. 12 equals a times 9. I divide both sides by 9, which gets me a equals did I do this right? Sorry, this should have been 6. 3 plus 3 is not 9, it's 6. Okay, this gets me a is 2. That sounds better. Now I'm going to rewrite the equation using all of my parts. So I have y equals 2 times x plus 3 times x minus 2. And my last step is to write it into standard form. Okay, to do that, I multiply out my factors. X plus 3 times x minus 2. I have x squared minus 2x plus 3x and minus 6, which becomes y equals 2x squared plus x minus 6. And multiply each term by 2, and I get y equals 2x squared plus 2x minus 12. And that's my final answer. Done. And that's how you write an equation from a table. Next page. Okay. Writing an equation from a graph is basically the same thing. You get your x-intercepts from your graph instead of your table. So we have our first step is the same. Step 1, get x-intercepts. Those are, I can observe, -3, 0, and, pardon me, 2, 0. So that's -3, 0, and 2, 0. Step 2, write as y equals a x minus something and x minus another thing. So this is going to be y equals a times x plus 3 and x minus 2. I know over here I have minus in general. This would have been x minus -3, but I'm just writing it as plus 3. Basically, I'm switching the sign. Step 3, use any third point to solve for a. I'll use this one because it's tidy and it's given to me. That's the point 0, 12, and I plug it in. So I have 12 equals a times 0 plus 3 and 0 minus 2. That's 12. Sorry, why is -12 here? -12, that's what my pause was. I knew I made a mistake because this is going to end up as a negative value, but I know that a needs to be positive because I'm opening up. Okay, -12 equals a times -6. Divide both sides by -6. And I get that a is +2. Step 4, write it out. This is y equals 2, x plus 3, x minus 2. Step 5, put it in standard form. So I need to multiply out my factors. This is x plus 3 and x minus 2 squared, 3x, -2x, -6. I get y equals 2, x squared plus x minus 6. Multiply the 2 to each term. I have y equals 2x squared plus 2x minus 12, and that's my final answer. Sometimes everybody, oh, that's that question. Next problem. Now we have an example with only one x-intercept. Okay, this one's a little bit different, but it's actually less work. Step 1. Get x-intercept. There's only one x-intercept. It's -3, 0. Step 2. Write as y equals a, that format. Okay, so I'm going to write this as y equals a x plus 3 times x plus 3. It happens to be that this has a special name. You don't need to know it at this level, but it's called multiplicity. This would be an x-intercept with multiplicity 2, and it just means that this is going to be squared. In any case, when you only have one x-intercept, you have this like special case where in order to solve, you only really need 2 points. Okay, step 3. Use any third point to solve for a. That's kind of deceptive because in this situation, it's not really a third point. I'm going to use this point right here, 0, -4.5. And I'm going to plug it in. So I plug in -4.5 for y equals a times 0 plus 3 times 0 plus 3. This becomes negative 4.5 equals a times 9. I divide both sides by 9. And I get that a is equal to 2. Step 4. Write it out. This is y equals 2 x plus 3. And I'm going to write this as x plus 3 squared. Deep breath. It means the same thing as that. X plus 3 times x plus 3 is x plus 3 squared. Step 5. Standard form. Okay. X plus 3 squared. Don't make the mistake where you lose your middle term. X squared, 3x, 9. This becomes y equals 2 times x squared plus 6x plus 9. I multiply the 2 to each term, and I get y equals 2x squared plus 12x plus 18. Oh, sorry, negative. This should have been negative 2. That should have been a negative 2. Here, here, and here. My mistake. Okay. The next page is just practice. It's not necessary for us to do all of them together, but I will do a few. I will do number 7, 10, and 13. Okay, I'm not going to write every single step, but I take my x-intercepts and I use those to start my problem. Y is going to be a times, don't forget to change your sign because you're doing the zero product property in reverse, x plus 2, x minus 3. Now I need to solve for a. I'm going to use that third point to do it. So this becomes negative 12 equals a 2 plus 2. I'm plugging in negative 12 for y and 2 for each of my x's. Times 2 minus 3, that's negative 12, equals a times 4 times negative 1. Negative 12 equals negative 4a, divide both sides by negative 4. And I get a equals positive 3. For these, I kind of don't care if you write them in standard form, but when we're being super formal, you should. For now, I'm just going to write this as 3 times x plus 2 and x minus 3. If you were to write it into standard form, you would multiply this out, but I'm not going to right now. Next problem, doing number 10. Okay, factored form. This is going to be y equals a. I'm going to use my x-intercepts, x plus 6, don't forget to change your sign, and x plus 3, don't forget to change your sign. Now I solve for a by plugging in my third point. Y becomes negative 6 equals a. X becomes negative 4 plus 6, negative 4 plus 3. This becomes negative 6 equals a times 2 times negative 1. Negative 6 equals negative 2a. So a is equal to, 3 again. Forgot. Anyway, this becomes y equals 3x plus 6 times x plus 3. There we go. Now I'm going to rewrite this equation in standard form. Okay, I multiply the factors together. X plus 4, x minus 2. This becomes x squared. X times 4 is 4x. X times negative 2 is negative 2x. 4 times negative 2 is negative 8. I combine my like terms. This becomes x squared plus 2x minus 8. And now I can't forget this negative, this 1/2. It's not negative though, sorry. Put that in front and then multiply it to each term. So this becomes y equals 1/2 x squared plus x, because 2 times 1/2 is just 1, minus 4, because negative 8 times 1/2 is negative 4. And that's it. Hope you enjoyed this video. Have a great day. Bye.